My name is Everett Brandt, and I was in charge of the Arduino programming.
My name is Zach Watkins, and I was in charge of the CAD files.
My name is Noangvith Harape, and I was in charge of the documentation.
My name is Carson Burson, and I was in charge of the MATLAB.
The purpose of the project is to be able to turn a DC motor into a servo by implementing PWM or pulse width modulation signals to detect the current position and to dial it to move to the target position. Here we have the block diagram that shows the purpose of each part of the project. We can either supply the MATLAB code or the Arduino code that feeds into the computer, which then goes into the Arduino microcontroller where it sends instructions to a motor controller that can either provide a positive or negative voltage into the DC motor, where it is connected to the potentiometer that sends the feedback voltage back into the microcontroller, or it sends the current and target position into the laptop where we can see. Next is the overall block diagram that shows the pinout of the system. Finally, here we have the schematic of the whole system. The power supply, which is right here, connects into the Arduino board where it connects to the potentiometer and the motor controller to give instructions into the DC motor.
For our second project, we needed to come up with two designs, one being the motor coupler, which was a design to allow us to attach one side of the DC motor output to the shaft of the potentiometer. And we needed to come up with a design that was short and compact enough, but yet large and strong enough so that the torque of the DC motor would not strip the coupler connected to the potentiometer. And you can see by inspection that the total length of this is only around 18 millimeters. So it gives us plenty of room to work with when we move over to the motor mount, which we can see is much larger at around 90 millimeters and a total height of only around 56 millimeters. And so what this does is this allows us to, if we get to the top, this allows us to connect the DC motor flush with this surface and the base of the potentiometer flush with this surface, where we would have the coupler attached to the DC motor in total length, and we'd have the output of that to the right of this. This needed to be large enough that this would not topple over, so that the potentiometer or the output of the DC motor would be able to have weights to it for the MATLAB script.
Our program consists of three main parts. We have our setup portion right here, we have our get set point portion right here, and we have our motor go section over here. So first we define our values, which literally just puts a placeholder in every variable for them later on. Things like our pins, which never change, and our constants, which never change. Here we use these constants in the PID object, my PID, which is inside the PID v1 library inside Arduino. We also define our pins as input and outputs and set the mode for automatic. Inside the get set point, again, this is an infinite loop, so it's constantly trying to get a set point. If the set point is actually there, this will produce a positive value, just to parse the set point from the serial monitor. That sets our global variable here, which we can then use in our motor go function. But first we compute our PID based on the potentiometer in value, and then we have our if-else statements, which simply change whether we're writing forward pin high and low or low and high. And then obviously if the potentiometer is the same as the set point, we write both of them as low as it's reached its set point. We also set the analog write to whatever the pulse modulated output is, which the PID computes. And that's essentially it. Since we use the PID library, it simple for the overall program.
The MATLAB code allows a user to interact with the motor by choosing a target position in a GUI that also displays the current position. MATLAB is set to control the Arduino. It reads in the voltage from the potentiometer feedback and converts it into a value between 0 and 300, which is also the amount of degrees that the potentiometer can turn. When a user clicks on a target position, it calls this event right here. In this event, it will turn the motor left or right depending on the current and the target values. This line here allows the speed from the motor to decrease from its max to minimum speed as the current position approaches the target. Once it reaches or passes the target value, the speed is turned off, and it's now ready for the user to make another selection.
The next step of the project will be adding different types of weights to this part of the DC motor so that I can change the speed of the tuning. We can't be doing this now since our DC motor doesn't have enough torque to turn any weight added on. So to change this project, we could be getting a new DC motor. Thank you for watching our video.